Namaste students, this is Subhadra Srinivas, Department of Mathematics, Sri Krishnaswamy College for Women, here to present to you all about what a transportation problem is and also to solve a given transportation problem as well. So let us see the definition of a transportation problem initially. Transportation problem is a special type of linear programming problem. It has a number of origins and destinations. The main objective of this is to transport various quantities of a commodity to different destinations such that the total transportation cost is minimum. In simple words, a linear programming problem that aims to minimize the total cost of transportation from the source of supply to the points of destination and demand is called a transportation problem. Initial Basic Feasible Solution, shortly called as IBFS. The transportation problem has a solution only if the problem is balanced. Therefore, before starting to find the IBFS, we have to check whether the given transportation problem is balanced. We can obtain the IBFS using any one of the three methods, namely 1. Northwest corner rule, 2. Least cost method, and 3. Vogel's approximation method. Method 1. Northwest corner rule, shortly called as NWCR. This is one of the most systematic and easiest methods of obtaining the IBFS. Now, let us see a problem based on this method. The question is, find the initial basic feasible solution, that is IBFS, of the following transportation problem using northwest corner rule. So this is the transportation table given to us along with the supply and the demand. Solution. Let us take the supply as AIs and demand as BJs. So in supply we have got three values, 4, 8 and 9. So sigma AI is nothing but 4 plus 8 plus 9, which gives us 21. And in the demand we have got 5 values. So sigma BJ is nothing but 3 plus 3 plus 4 plus 5 plus 6, which is also 21. So it is clear that sigma AI and sigma BJ are equal. So since both these values are equal, we say that the given transportation problem is balanced. Hence, there exists an IBFS to this transportation problem. So let us proceed to find it. According to northwest corner rule, NWCR, the first allocation is made in the top leftmost corner cell of the table. Step 1. Now, let us first place all the given values in the top leftmost corner of each cell inside the transportation table. So, the first work is to identify which is the northwest corner cell of the table. So, this is the northwest corner cell of the table with the value 2. So, we are going to start accommodating the values from this cell. So, the next work is to see both the values horizontally and vertically straight to that particular cell which we have selected. So, horizontally we see that there is value 4 and vertically we see that there is value 3. So, among this 3 and 4, we see that the minimum value is 3. The minimum value 3 is placed inside the cell and the same minimum value is subtracted from the maximum value 4 and kept aside. So, the newly obtained value is 1. Now, the column straight to the minimum value is going to be eliminated and the newly obtained value 1 will replace the value 4 in the next step of the transportation problem. So, now step 2. The resulting reduced transportation table is this. So, now again we are going to follow the same method. What do we do? Is to identify the northwest corner cell of the transportation problem. Now the northwest corner cell is going to be this one, the cell with 11. And now we see both the corresponding values to the cell horizontally and vertically. We have got 1 and 3, of which the minimum is 1. So, the row straight to 1 is going to be eliminated and this minimum value is going to be placed inside the cell and the same minimum value is going to be subtracted from the maximum value. which will give us 3 minus 1, 2. Now, this row is going to be eliminated and this maximum value 3 is going to be replaced by the newly obtained value 2 in the next step. Step 3. We have the following table now. So, we have the table with 2 rows and 4 columns as shown here. Now, again the northmost corner cell is going to be this, the value with 4. Here we see both the corresponding values straight to this horizontally and vertically, which is again 2 and 8, of which the minimum value 2 is placed inside and this column is going to be eliminated and the maximum value and this minimum value is subtracted and the newly obtained value is 6. So now when we proceed to the next step, this column is going to be eliminated and this maximum value 8 is going to be replaced by the newly obtained value 6. Now step 4. So again we are going to repeat the same procedure. This cell is selected. The two values are 4 and 6. Minimum is 4, which is placed inside, and this corresponding column is eliminated and 4 is subtracted from 6 and we are getting the value 2 here. So 6 is going to be replaced with 2 in the next step. So step 5, we have got only 2 rows and 2 columns. So again we are going to select this northwest corner cell 2 and the corresponding values are 2 and 5, of which the minimum 2 is placed inside and the corresponding rows eliminated, and from the maximum value 5 the minimum value 2 is being subtracted, which gives the value 3. So in the next step 5 is going to be replaced by the value 3 and this corresponding row is going to be eliminated. So step 6. Finally we have got only 2 cells. So this is going to be the leftmost cell and here we have got 3 and 9, of which the minimum is 3, which is placed inside, and from the maximum 9 this 3 is being subtracted. So I am writing it as 9 minus 3, which is 6. So 9 is going to be replaced with 6 in the next step and this cell is going to be eliminated. So the final step is step 7, where we have got only one cell. So there is no other option other than accommodating inside that cell. So we've got both the values equal, 6 and 6. So that is only the minimum which is going to be placed inside. So now we have allocated all the values in their respective cells in the transportation problem. So finally the IBFS is presented as follows. So now I've drawn the given transportation table with all the questions which were given, with all the accommodations we did in all the 7 steps inside each cell. So here from this table we see that the number of allocations is 7, that is 1, 2, 3, 4, 5, 6 and 7. So there are 7 allocations. Now the next task is to check whether m plus m minus 1 and the number of allocations are equal. M and n are nothing but the number of rows and columns of the given transportation problem. So here we see that the number of rows is 3 and the number of columns is 5. So m is going to be 3 and n is going to be 5. So m plus n minus 1 is nothing but 3 plus 5 minus 1, which is also 7. So we see that both the number of allocations and m plus n minus 1 values are equal. Thus the solution is a non-degenerate basic feasible solution. So finally the initial transportation cost is calculated. How to calculate this is, we are taking only the cells with the allocated values and multiplying both the respective values and adding up all of them. So the first cell we have got 2 and 3. So we are multiplying 2 into 3 in the first bracket, plus the second allocated cell is this 11 into 1. So here 11 into 1, plus the next one we have got 4 into 2. So 4 into 2, we are adding that also. The next one is 7 into 4, then 2 into 2, then 8 into 3 and finally 12 into 6. So we are adding up all the values and finally we have got the value 153. So this is going to be the initial transportation cost of the given transportation problem. So this is how we solve a given transportation problem using northwest corner rule. Thank you, students.